Hello friends, today we will take one problem on Fourier series. So problem express f of x is equal to 0, minus pi is less than x is less than pi, and sin x 0 is less than x is less than pi as a Fourier series. Means simply we have to find Fourier series of this function f of x equal to 0 if x lies between minus pi to 0 and sin x if x lies between 0 to pi. Actually interval given a minus pi to plus pi, and minus pi to plus pi is splitted in two parts here, minus pi to 0 and 0 to pi. So minus pi to plus pi means minus L to plus L equate with minus pi to plus pi, so L equal to pi, this is fixed now. But if interval is minus pi to plus pi, then we have to check, or minus L to plus L, then we have to check given function is even or odd. So how we check? By putting x equal to minus x. So f of x is equal to this given function. Now in this function, if you put x equal to minus x, then f of minus x equal to 0. Here minus pi is less than minus x is less than 0, and sin of minus x 0 is less than minus x is less than pi. Now in next step, here minus x is, we have to change this minus x, means if you multiply here throughout minus 1, then less than become greater than, so this minus pi becomes pi, and less than means pi is greater than x is greater than 0, that is this pi is greater than x is greater than 0 equal to 0, and sin of minus x is minus sin x. So same here, if you multiply by minus 1, then 0 is greater than x is greater than minus pi, that is minus pi is less than x is less than 0. So this is not equal to f of x, or not equal to minus time f of x, because f of x is this, so we can say that f of x is neither even nor odd function. And if f of x is neither even nor odd function, then in this problem we have to find a0, then an, after an we have to find a1, after then a1 we have to find bn, then after bn we have to find b1. So why we find here a1 and b1? Because f of x involves sin x here. Okay, so we will find one by one. So what is formula? A0 is equal to 1 upon L minus L to plus L f of x dx. So L is pi here, so 1 upon pi minus L to minus pi to plus pi. In minus pi to plus pi, f of x is given this, so we have to split f of x in two parts, minus pi to 0 and 0 to pi. So if you write this minus pi to plus pi, becomes first minus pi to 0. In minus pi to 0, f of x is 0, so value of that integral is 0, plus 1 by pi into integration of 0 to pi. In 0 to pi, f of x given is sin x dx. So what is integration of sin x? Integration of sin x is minus cos x here. Limit varies from 0 to pi. So if you put upper limit here, upper limit is minus cos pi, and lower limit is cos 0, minus cos pi plus cos 0, but cos pi is minus 1. So minus minus plus means 1 plus 1, cos 0 is also 1, so 1 plus 1 is 2, so a0 is equal to 2 upon pi. Similarly, next constant is an. So how we find an? Formula 1 upon L minus pi to pi, 1 upon L minus L to plus L f of x cos n pi x by L dx. But L is pi here, so 1 by pi minus pi to pi f of x cos nx dx. And minus pi to pi again divide in two part, minus pi to 0 and 0 to pi. In minus pi to 0, f of x is 0, so in 0 to pi, f of x given is sin x. So this is 1 upon pi integration of 0 to pi sin x into cos nx dx. Okay, now how we find integration of sin x into cos nx? So we have to use your sin a cos b formula. So what is sin a cos b? Sin a cos b can be written as 1/2 times sin of a plus b plus sin of a minus b. Take a equal to x, b equal to nx. So can be written as 1/2 means 1 upon 2 pi, this 1 by pi, and 1 by 2. The formula sin a cos b is 1 by 2, that is 1 by 2 into sin of a plus b, sin of x plus nx, take x common, sin of 1 plus n into x, plus sin of a minus b, x minus nx, take x common, 1 minus n into x. And so this is using sin a sin b, we get this term. Okay, now we have to find integration of this term. So 1 upon 2 pi as it is, integration of sin is minus cos of 1 plus n into x upon 1 plus n. Same integration of this sin is minus cos of 1 minus n into x upon 1 minus n. Limit varies from 0 to pi. Now if you put upper lower limit here is equal to 1 upon 2 pi into minus sign, this minus sign as it is here, and upper limit x is equal to pi, if you put here then we get cos of 1 plus n into pi. What is the value of cos n pi? Cos n pi is minus 1 raised to n. So in that if you put n equal to 1 plus n, then cos of 1 plus n pi is minus 1 raised to 1 plus n. Minus, same here if you put x equal to pi upper limit, so cos of 1 minus n pi. Cos of 1 minus n pi, again minus 1 raised to 1 minus n. Lower limit, minus sign and this minus sign plus. So if you put here lower limit x equal to 0, then cos 0 is 1, so 1 upon 1 plus n. Again here minus sign, a lower limit minus, that is plus. Put x equal to 0 here, cos 0 is 1, so right here 1 upon 1 minus n. So this is after putting limits upper minus lower. Now here minus sign, minus 1 into minus 1 raised to 1 plus n, and here also this minus 1 raised to 1 minus n. Means we can write here this is equal to 1 upon 2 pi into minus 1 raised to n upon 1 plus n plus minus 1 raised to n upon 1 minus n, plus take cross product here, this 1 plus 1 minus n plus 1 plus n upon 1 plus n into 1 minus n. But how we write this minus 1 raised to n? Minus 1 raised to 1 plus n can be written as minus 1 into minus 1 raised to n, so minus minus plus. Same here, minus 1 into minus 1 raised to minus n, that is minus minus plus. Okay, so or minus 1 raised to 1 plus n is always equal to minus 1 raised to 1 minus n. Minus 1 raised to 1 plus n is always equal to minus 1 raised to 1 minus n. And if you write minus 1 raised to 1 plus n is minus 1 into minus 1 raised to n, then this minus plus, here also this minus plus. So we get here minus 1 raised to n, here also minus 1 raised to n upon 1 plus n, 1 minus n, this as it is. And for this term take cross product, that is mention here 1 minus n into 1 plus 1 minus n upon 1 minus n plus 1 minus n, 1 minus n plus 1 plus n here, not minus, 1 minus n plus 1 plus n. So n get cancelled, then here 2. Okay, so here not minus sign, here this sign should be plus. Okay, then from these two terms if we take minus 1 raised to n common, and again if we take cross product here, 1 minus n plus 1 plus n, so n get cancelled upon 2 into, means this is numerator is 2 here and denominator is 1 plus n into 1 minus n, that is 1 minus n square. Same here, this 2 upon 1 minus n square. So you can take this 2 upon 1 minus n square common. So if you take 2 upon 1 minus n square common, then we will get this 2 to get cancelled. Okay, and this 1 minus n square as it is into pi, this is the denominator, and in numerator here 1 plus minus 1 raised to n. So observe, this is a n, this is the value of a n. In Fourier series n starts from 1. So if we put n equal to 1 here, then we get denominator 0, 1 minus 1 is 0. So this is true for n is not equal to 1, means for n is greater than 1. Because in f of x sin x present is, so we have to find for n equal to 1, we have to find a1 separately. So how we find a1? In original formula, means in this formula, put here n equal to 1, then a1 can be written as 1 by pi into minus pi to plus pi f of x cos x dx. That is 1 by pi into minus pi to plus pi, minus pi to 0 and 0 plus 0 to pi. So in minus pi to 0 f of x is 0. So 1 upon pi integration of 0 to pi f of x is sin x into cos x dx. Now how we find integration of sin x into cos x? Multiply and divide by 2 here. If you multiply and divide here, if you divide by 2, then we have to multiply here by 2. So 2 sin x cos x is sin 2x right here. Okay, now what is integration of sin 2x? Is it minus cos 2x upon 2, this one. So 1 upon 2 pi into minus cos 2x upon 2, limit varies from 0 to pi, is equal to this 2 into this 2, that is 4. So 1 upon 4 pi into upper limit, if you put x equal to pi here, then minus cos 2 pi minus minus plus cos 0. Cos 2 pi is 1, so minus 1 plus cos 0 is 1 plus 1 equal to 0. So the value of a1 is 0. Then we have to find bn. So bn is equal to, again formula here directly mentioning 1 by l. Actually formula 1 by l minus l2 plus l f of x sin n pi x by l dx. but L is pi here, so 1 by pi minus pi to plus pi, but minus pi to plus pi, if we split minus pi to 0, in that f of x 0, plus 0 to pi, in 0 to pi f of x given is sin x. So we have to find bn for 0 to pi only. So bn equal to 1 by pi integration of 0 to pi sin x into sin nx dx. Now how we find this? For integration we have to use sin a sin b formula. So what is sin a sin b formula? I think sin a sin b can be written as 1 half times cos of a minus b into x minus cos of a plus b into x. So 1 half times means 1 upon 2 pi into integration of 0 to pi cos of a minus b. A is x, b is nx. So cos of x minus nx, take x common, cos of 1 minus n into x, minus cos of a plus b, x plus nx, that is take x common, 1 plus n into x dx, is equal to 1 upon 2 pi into integration of cos is sin of 1 minus n into x upon 1 minus n, minus integration of this cos is sin of 1 plus n into x upon 1 plus n. Limit varies from 0 to pi. So your limit 0 to pi, if you put upper and lower limit both here, then we know that sin n pi is 0 for all values of n. So sin of 1 minus n into pi is also 0. Sin of 1 plus n into pi is also 0. Okay. So upper limit is 0, lower limit sin 0 is also 0. So bn is equal to 0 when? For n is not equal to 1, because if you put n equal to 1 here, then we get 0 by 0 form. For x equal to pi, sin of 1 minus n pi is 0, and for n equal to 1 here 0. So 0 by 0 is indeterminate form. So bn is equal to 0 when? If n is greater than 1. So for n equal to 1, again we have to find b1. How we find b1? In this bn, put n equal to 1 here. So if you put n equal to 1, then b1 can be written as 1 by pi 0 to pi sin x into sin x dx. Means here 1 by pi 0 to pi sin x into sin x dx. So sin x into sin x is sin square x. So next step is here directly mention a 1 by pi 0 to pi sin square x dx, and we know that if n is even, power of sin is even, then we can write using conversion formula 2 times 0 to pi by 2 sin square x dx. And how we integrate this 2 times 0 to pi by 2 sin square x using reduction formula? This 2 by pi as it is, okay, and its integration is 2 minus 1 upon 2 into pi by 2, that is 2 minus 1 is 1 by 2 into pi by 2. So this pi get cancelled, 2 get cancelled, so b1 is 1 by 2. Now we have to write Fourier series of given function. So in this problem we already find a1, b1, a0, an and bn. So we have to expand that series for n equal to 1. So how we write Fourier series? Formula is f of x is equal to a0 by 2 plus summation of n varies from 1 to infinity an cos n pi x by l plus bn sin n pi x by l. But we know a1 and b1 here. So expand that series for n equal to 1 first. For n equal to 1, how we write this? An cos nx can be written as a1 cos x plus b1 sin x. Okay, and then plus summation of n starts from 2 to infinity an cos nx plus bn sin nx. Now here f of x is given function, not only sin x, that is 0, and sin x is equal to a0. What is the value of a0? a0 is 2 by pi. So a0 by 2 means 2 by pi upon 2, that is 2 get cancelled, so 1 by pi here, plus the value of a1 is 0. So a1 into cos x is there here, a1 into cos x plus here b1 into cos x. So a1 is 0 plus b1 is 1 by 2 cos x here cos x is missing, cos x and plus summation of n varies from 2 to infinity an 1 plus minus 1 raised to n upon pi into 1 minus n square cos n x, and bn is 0. Okay.